Hey guys, welcome back to my channel. Today, based on the title, we will be working on simplifying radical numbers. This is going to be a two-part video. This worksheet will be the same worksheet that we will be using for both videos, but for today only, we will just be working with the positive numbers in a radical. So let's jump into the video. So of course, before you guys get started, I'm going to give you guys step-by-step instructions as to how to solve each question. So the first one says, think of two numbers you can multiply to get the number in the radical, which is also called a radicand. One of your numbers should be a perfect square, the other should be in its smallest form. 3, group both in a radical. 4, separate both numbers in their individual radicals. And 5, simplify the perfect square, then write the remaining radical with the number to the perfect square. Again, a lot to know, but we're going to do it step by step to simplify. Here, I created a little chart with perfect squares from 1 through 30. Which I normally give my students to help them, especially if they don't know perfect squares. The square on the top, on the reverse, I wrote it out. So 1 times 1, 2 times 2, 3 times 3, and I color coded to help students differentiate. Okay, so for our example for today, we're gonna do number 1 and number 2 of the worksheet. So the number 1 says radical 343. Number 2, radical 112. I'm going to grab my square root perfect square chart. And here is where it gets a little bit more complicated. So our first step says, think of two numbers I can multiply to get the number in the radical. So I'm going to grab my calculator. And I'm going to divide 343 by each perfect square to see which one I can pair up to get 343. I started with perfect square 4 because any number you multiply 1 by, you're going to get that number again, and we don't want that. So I'm going to multiply each perfect square to see which one will give me a whole number, because entirely we don't want a decimal. We want a whole number. So I'm dividing 343 by each perfect square. I'm at 49, so I realized that 49 times 7 will give me 343. I'm then going to try 64 to see if that will give me a whole number or will it give me a decimal. So I realized after dividing up to 100, I realized that the only number that can work is 49 times 7, right? So I write that to the side, bring an arrow to remind me that, okay, 49 times 7 is the numbers. I'm going to read step number 2. One of your numbers should be a perfect square, which we know in this case our perfect square is 49, and our other number is 7. So we move on to step 3. Group both numbers in a radical. Step number 4, separate both numbers in their individual radicals. Step number 5, simplify the perfect square, then write the remaining radical with the answer to the perfect square. So we know that if we grab a calculator and we put both of these numbers in a square root, so square root 49 gives us 7. And if we square root 7, we're going to get a decimal, which is not what we want. So we put it as 7 radical 7 as our answer. On to question number 2. So radical 112 is our next one. Again, step by step, we're going to think of what two numbers can I multiply to get 112. What we're going to do to break it down, we're going to divide at first, right? So we grab a calculator and we divide 112 by each perfect square to see which one will make a pair. Of course, we're going to skip one because any number you divide by 1, you're going to pretty much get that number back. So we know that we can multiply 28 times 4. We divide 112 by 9. That doesn't work. We do 112 by 16. We know that 16 times 7 will work. 112 times 25 won't work. So far we know that we only have 2 solutions. And we're going to try to prove it until we get to about 64. So now that we see that we only pretty much have 2 solutions at this time, we move on to step 2. So we're going to look for a perfect square, and the other number should be in its smallest form. Now, for the first one, it's 28 and 4, which 4 is our perfect square. 28 is the other number. It clearly is in its smallest form. The other pair is 16 and 7, which we know 16 is our perfect square and 7 is the other number, which is in a smaller form. So we know our solution here would be 60, our pair would be 16 and 17. We're then going to put 16 and 7 in their own, well, we're going to group them together, step 3, in a radical. We're then going to separate them in their individual radical forms, and then we're going to simplify. Now we know that in this case, our perfect square is 16. So radical 16 is our perfect square. To prove ourselves, we're going to put it in the calculator. Radical 16 is 4. What's left over now, the remaining radical, you're going to add that, which is radical 7, to our answer, and our answer is 4 radical 7. So we're going to move on to question number 3, the last example. And of course, we're going to have our step-by-step to help us to recall what we should do. We're going to think of 2 numbers that we can multiply to get 54. But first, we got to do the inverse. So we're going to divide 54 by each perfect square. We're going to do it from 4 all the way to probably 49. And see, the only pair that we have found so far is that 9 times 6 gives us 54. We're going to do it again till we get to about 49 to see which one doesn't give us a decimal but gives us a whole number. So we realize that our pair is 9 times 6. We're then going to combine both of them in a radical. Then we're going to separate them in their individual radicals. And then we're going to simplify. And that is the answer for number 1, number 2, and number 3. I hope today's video gave you a better explanation of how to solve radical numbers, or if you didn't know how to solve it before, it gave you that lesson of how to solve it. There will be a part 2 of how to solve the negative radicals or imaginary numbers. Thank you guys again for watching, and I will see you guys in my next video. Peace.